Friends, welcome back to Engineering Mathematics 2. So far, I think we have discussed about the concept of a differential equation, order and degree of a differential equation, ordinary differential equation, and how we are going to write down the general solution of a differential equation, and what are the characteristics of a solution of a differential equation, right? And how we are going to write down general solution of the given differential equation. It means by using a superposition principle, how we are able to write down the general solution of the given differential equation, and after that we want to write down the given differential equation in standard form. Standard form means say for example, the given differential equation is containing term dy by dx or d square y upon dx square, right? And d by dx can be replaced by capital D, as clear, that we call it as an standard form, right? And after that we want to replace capital D by m, right? So you will get an algebraic equation, right? So once we are able to obtain an algebraic equation, immediately we want to find out roots of the algebraic equation, right? So for example, you may get roots real and equal, or sometimes you may get real and different, right? Sometimes we may obtain complex roots, right? So in all these cases we want to write down a general solution of the given differential equation, right? So we have already practiced all those things, right? So along with these things we have also discussed when we get real and equal roots, what is the physical meaning of that, or real and unequal complex roots. I think in the last session we have discussed about so what do you mean by overdamped motion, right? Especially in case of a spring mass system, what do you mean by critically damped motion, right? And what do you mean by underdamped motion? That's clear. Along with the mechanical vibrations, yesterday we have discussed a little bit about electrical sciences. It means what is the role of second order differential equation in electrical sciences. It means we have discussed the same characteristics what we have discussed in case of mechanical vibrations, namely overdamped motion, critically damped motion, underdamped motion, right? So we have discussed the same thing in case of electrical sciences, right? So along with these things we have also discussed non-homogeneous second order linear differential equation with constant coefficients, and we have also given interpretation of initial value problem, how we are going to find out period and frequency, right? So friends, so far we have discussed all these things, right? So now we want to move on to the non-homogeneous differential equation. Is it clear, right? So suppose if the given equation is an non-homogeneous differential equation, how we are going to find out the solution of non-homogeneous differential equation, right? Now first we want to identify whether the given equation is an homogeneous equation or non-homogeneous equation, right? So it is very simple to identify. We want to observe the right hand side member, right? It may be of the function of x or it may be of the function of t. Is it clear, right? Sometimes we can use the variable x or sometimes we can use the variable t, right? So we want to verify whether it is a non-zero term or a zero term. If the right hand side is a zero term, then we call such a type of equations as a homogeneous equation, right? If the right hand side member is non-zero, then we call it as a non-homogeneous differential equation. Is it clear, right? Suppose if the given equation is an non-homogeneous equation, how we are going to find out the solution of such a type of differential equation, right? So we shall discuss such type of things in the present session, right? So once again we can take the help of superposition principle. By using superposition principle, we are able to write down the general solution of a non-homogeneous equation. Is it clear, right? Now as I have mentioned, today we shall discuss about non-homogeneous equation, right? So it means it is understood that a right hand side member is not equal to 0. Is not equal to 0 means what, right? What is the form of the right hand side member, right? It may be of the various type. Is it clear? For example, it may be of the type e raised to ax, right, where a is some constant, or it may be of the type x raised to m, right, or it may be of the sin ax, or more generally we may say that sin of ax plus b, where a and b are some constants. Is it clear? Or it may be of the cos of ax, or more generally cos of ax plus b, right, or it may be of the type x into v, again v may be a function of x. Is it clear? And finally it may be of the type e raised to ax into v, right, again v may be a function of x, right. So friends, in all these cases how we are going to find out the general solution of the given differential equation. Is it clear? Right. So when we talk about general solution in case of non-homogeneous differential equation, it is understood that right, the general solution of the given differential equation is containing two parts, right. So first part is complementary function and second part is particular integral, right. So we are already familiar with the first part. First part means how we are going to calculate complementary function. Is it clear? Now, as usual, we want to obtain an algebraic equation, find out the roots. Depending upon the nature of the roots, we are able to write down the complementary function, right. And depending upon the right hand side member means right hand side function may be any one of these forms, right. So according to that we want to calculate a particular integral. Is it clear? Right. So in this session I want to focus on how we are going to calculate a particular integral. Is it clear? Right. In all these cases, and I will try to solve at least one example on these cases, right. If time permits, so we shall discuss about the method of undetermined coefficients. Is it clear? Right. So it is also an method to calculate or to find out a particular integral of the particular function. Is it clear? Right. So when the right hand side member of these types, we can use a method. Sometimes we have to use another method, namely undetermined coefficient, or we can use a method of variation of parameters. So it means we can use these two methods to find a particular integral. I will explain how we are going to use those two methods to calculate a particular integral, right. Okay. Now I want to concentrate on when the right hand side member is of the type e raised to ax, how we are going to calculate an particular integral. Is it clear? Right. So when the right hand side member f1x is of the type e raised to ax, right. So friends, as I have mentioned, given differential equation can be written down in symbolic form. Symbolic form means it is very simple. As I have mentioned in the earlier cases, d by dx or d by dt can be replaced by capital D. Is it clear? And after that you can take the coefficient of x or coefficient of y as a function of d. Is it clear? And it can be written as a particular integral is equal to 1 upon f of d into e to the power ax, that is equal to 1 upon f of a e to the power ax. Friends, it is very simple to calculate particular integral in case of e to the power ax. Wherever d is there, no, simply I have to replace d by a, right. I hope you will get f of a. Then you may ask, what do you mean by f of a? F of a is a simple constant, right. So it may be a constant. Is it clear? Then I have to verify whether f of a is equal to 0 or not equal to 0. Is it clear? Right. So suppose f of a is not equal to 0, that is one case. Is it clear? Right. Then this quantity becomes the particular integral of the given function, right. So when f of a is equal to 0, is it clear? Right. For some d is equal to a, f of a is equal to 0 means what? F of d is equal to 0. It means a is one root of f of d. Is it clear? Right. Or what we can say that you can replace d by m, f of m. Is it clear? Right. So d is equal to a, then the above method fails. It means when f of a is equal to 0, then we cannot use this method. In such cases we proceed as follows, right. So it means if a is one root of f of d is equal to 0, then particular integral is equal to x into e raised to x divided by some function of a. Some function of a means suppose if it is a second degree polynomial in D. So, we will get two factors, one factor may becomes 0, another factor may not be equal to 0. In that case, you want to ignore a factor which is becomes 0, you want to consider a factor which is not equal to 0, and that can be write down in this form, and we can take it as a particular integral, right, when f of a is equal to 0. Is it clear, right? And similarly, if a is double root of f of d is equal to 0, you assume that f of d is a second degree polynomial, right. So, a is repeated roots, in that case also f of a is equal to 0 or f of d is equal to 0. In that case, how we want to write down a particular integral? It is very simple, you want to write in this form, x square into e raised to x divided by 2 times of some function of a. Is it clear? Again it is a constant, 2 into some function of a is a constant, right. So, by using these rules, now we are able to find out a particular integral in case of e to the power ax. Is it clear? Now, before solving the example, just I wanted to give an information about superposition principle. Is it clear? Because we are going to use a superposition principle while writing the general solution. Is it clear? Right. So, if y1 is a solution of a into y double prime plus b into y single prime plus c into y is equal to f1 x. Is it clear? So, when we observe this equation, immediately we will come to know that it is an non-homogeneous differential equation, because it is containing derivatives, right, as well as a right hand side member f1 x is not equal to 0. Is it clear? And y2 is a solution of a into y double prime plus b into y single prime plus e into is equal to f2y. It is also an non-homogeneous equation. Is it clear? Then y is equal to c1 y1 plus c2 y2 is a solution of a into y double prime plus b into y single prime plus c into y is equal to c1 f1 x plus c2 f2 x for any constants c1 and c2. Is it clear? The complete solution of non-homogeneous equation is of the form complementary function plus particular integral, or in short form we can write down y is equal to cf plus py. Is it clear? Now, I have already explained superposition principle in case of a homogeneous equation exactly in the similar way. Now, we can use superposition principle in case of a non-homogeneous equation, right. So, friends, now we are familiar with the method. Now, we are familiar with the method means when the right hand side member is of the type e raised to ax, how we are going to calculate general solution of such type of differential equation. Is it clear? Why can't we solve one such type of example? Is it clear? Right. So, here it is given that d square y upon dx square minus 2 times of dy by dx plus y is equal to 3 times of e to the power 5 by 2 x. So, this is an given example, right. You observe the right hand side member is not equal to 0. So far whatever we have solved, all the equations containing 0. Is it clear? That is why we called such type of equations as a homogeneous equation, right. Here right hand side member is not equal to 0, that is why it is a non-homogeneous equation, right. So, now we shall think how we are going to find out the solution of this equation. Is it clear? As I have mentioned, solution may contain two parts, complementary function as well as a particular integral, right. So, we are already familiar with the complementary function. Is it clear? Now, first you want to write in a symbolic form, right. So, we can replace d by dx by capital D. It can be written as d square minus 2d plus 1 into y is equal to, you can write down as it is. Is it clear? Right. And if you replace d by m, I hope you will get m square minus 2m plus 1 is equal to 0, or you can write down m minus 1 whole square is equal to 0, right. So, you can write down either d is equal to or m is equal to 1, right. So, I hope we will find out the roots from the auxiliary equation, right. M is equal to 1 or d is equal to 1. How many times? 2 times. Here you will get only 2 roots. So, why you will get only 2 roots? Because the given equation is an second order differential equation. That is why we are able to obtain only 2 roots. Is it clear? Right. So, roots are real and equal on the basis of superposition principle. So, we can write down a complementary function is equal to C1 plus C2 into x e to the power x. Is it clear? So, is the complementary function of the given differential equation. Right. So, now we want to find out, or we want to concentrate on how we are going to calculate a particular integral. Right. So, therefore, Pi is equal to 1 upon f of d, as I have mentioned in the last slide. Is it clear? Right. So, f of d means what? Symbolic form of this. It can be written as a d square, right, minus 2d plus 1, what I have written here. Is it clear? Into right hand side member as it is 3 into e to the power 5 by 2 x. Is it clear? Right. Now, as I have mentioned, our method says that in this case simply we have to replace d by a, right, capital D by a. Here a means what? A means they have given 5 by 2. Is it clear? Right. So, replace d by 5 by 2 whole square minus 2 times of 5 by 2 plus 1. Is it clear? Now, what I have written here, 3 is constant, you can keep 3 as it is, right, 1 divided by as it is into e to the power 5 by 2 x, right, 3 1 divided by, I have replaced d by 5 by 2. Is it clear? Whole square minus 2 times of 5 by 2 plus 1, right. So, it should be only e to the power 5 by 2 x. So, I have written 3 2 times. So, you should not write 3 2 times, it should be e to the power 5 by 2 x only. Is it clear? Right. And I have to simplify 5 by 2 whole square minus 2 into 5 by 2 plus 1. After simplification, I can obtain 12 by 9 times of e to the power 5 by 2 x is the particular integral of the given differential equation. Right. So, hence by principle superposition principle, we can write down the general solution. Is it clear? So, y of x is equal to complementary function plus particular integral, or you can combine these two solutions. Is it clear? Y of x is equal to C1 plus C2 x into e to the power x plus 12 by 19 e to the power 5 by 2 x is the solution of the given differential equation. Right. I hope exactly in the similar way you can collect some more similar type of examples, right. So, right hand side member may be of the type e to the power ax, right. Find out complementary function and try to find out particular integral. Okay. Right. So, now we shall move into the another method. It means when the second member or right hand side member is of the type x raised to m, where m is a positive integer. In that case, how we are going to find out the particular integral. Is it clear? Right. Now, as usual, given equation can be written down in a symbolic form. Right. Then you can take f of d. You can write down particular integral is equal to 1 upon f of d into x to the power m. Is it clear? Right. So, from f of d, take out the lowest degree term, and the remaining factor will be of the form 1 plus or minus some function of d. It means, so this is f of d. Friends, we have to identify the lowest degree term from f of d. Is it clear? And you can take out the lowest degree term, and remaining thing can be written in this form. Is it clear? And after that, take this term to numerator with negative index. Is it clear? And expand it binomially. Expand only up to the terms where the index of d is m. Is it clear? Because d raised to m plus 1 when operated on x raised to m will be 0. Is it clear? Alright. So, you observe right hand side member x may be x to the power m, where m may be a positive integer. Right. Now, as I have mentioned in step 1, simply or you can identify the lowest degree term, take out the lowest degree term, it can be write down in this form, then remaining factor can be write down in a numerator with negative index. With negative index means to the power minus 1. Is it clear? Right. So, now you can operate d on this function, right. So, you know the meaning of capital D, is it clear? D is an operator, is it clear, right. So, when you operate D on this function, D means what? Differentiation, differentiation of x raised to m. Okay, I can find out. So, for example, m is 2, right. Right hand side member is of the form x to the power 2, is it clear? If I operate D on x square, it means I can find out the derivative of x square, is it clear? I can find out d square of x square. D square of x square means what? Second derivative of x square, is it clear, right? So, what about the third derivative of x square? So, third derivative of x square becomes 0, because derivative of x square is 2x. If I differentiate 2x one more time, I will get 2, right. If I differentiate 2 one more time, it becomes 0. So, that is why method says that, right. So, d raised to m plus 1 when operated on x raised to m, it becomes 0. It means third derivative of x to the power 2 becomes 0, or in general d to the power m plus 1 when we operate on this function, and that becomes 0. Is it clear? That is why we want to expand up to d to the power m. Is it clear? How we are going to expand? Binomially. Is it clear? Right. So, I hope method is clear. Now, we can solve one similar type of example, right. Here you can observe one more thing, right. So, right hand side may be of this form, or it may be a polynomial. Is it clear? Right. It may be of the type x square or x cube, x to the power 4, x to the power 10, any constant, or sometimes it may be a first degree polynomial, second degree polynomial. Is it clear? Right. Now, you observe in the given example, it is given that d square y upon dx square plus dy by dx is equal to x square plus 2x plus 4. Is it clear? It is a polynomial, right. So, now we can find out the general solution of this equation. When we talk about general solution of a non-homogeneous equation, it is a non-homogeneous equation, right. How do you say that it is a non-homogeneous equation? Because second side member is not equal to 0, right hand side is not equal to 0, that is why it is a non-homogeneous equation, right. So, first we want to find out a solution of the homogeneous equation by replacing a 0. Is it clear? We want to find out a complementary function. Is it clear? How we are going to find out complementary function? As usual, right. Replace d by dx by capital D, then replace d by m. I hope we can obtain the algebraic equation m square plus m is equal to 0. Is it clear? Right. M into m plus 1 is equal to 0, right. So, I hope we will get m is equal to 0 and d is equal to minus 1. Is it clear? Or m is equal to minus 1. Is it clear? It means roots are 0 and minus 1, right. So, now we are able to write down a complementary function, right. So, C1 plus C2 into e to the power minus x. Is it clear? Right. How do you say that? You will get C1 plus C2 into e to the power minus x, because roots are 0 and minus 1, right. So, if you want, we can write down C1 into e to the power 0x plus C2 into e to the power minus x. So, e to the power 0 means it is 1, that is why first term becomes C1 only. Is it clear? Right. Plus C2 into e to the power minus x. Because of the nature of roots, we are able to obtain this type of complementary function. Is it clear? Right. So, now we want to find out a particular integral, right. Now, first you can write down in this symbolic form 1 upon, right. It can be, this term can be written as a d square, second term can be written as a d. Is it clear? Right. Into the right hand side member, whatever they have given, I have written the same thing, x square plus 2x plus 4. Is it clear? Right. So, I want to simplify, 1 upon f of d can be written as 1 divided by, from these two terms I want to take out lowest degree term. What is the lowest degree term? D is the lowest degree term. Is it clear? It can be written as 1 divided by d into d plus 1, right, into given function right hand side member as it is. Is it clear? Right. According to the method, I want to take d plus 1 to the numerator with negative index. Is it clear? Right. So, I will write 1 upon d as it is, and I have written d plus 1 to the power minus 1 in the numerator. Is it clear? Into the right hand side member. right. So, that is equal to 1 upon d into, so now I want to expand 1 plus d to the power minus 1 binomially. I hope you will get 1 minus d plus d square minus d cube plus d raised to 4. Is it clear, right? So, you may ask up to how many terms we can write, whether can I write up to d raised to 4 or still I want to write a few more terms. Is it clear? That depends upon right hand side member, that depends upon this function. Is it clear? The power of x is 2 or the highest power of x is 2. Is it clear? I think these two terms are not necessary. Is it clear, right? If you write, no problem, but it is not necessary. Just now I have explained, when we operate d cube on x square, it becomes 0. When we operate d raised to 4 on this function, all the terms becomes 0, right. Say for example, next term I hope you may get d to the power 5. So, when we operate d to the power 5 on this function, it becomes 0. That is why I think next terms are not necessary. Is it clear, right? So, if you want, you can write down up to d square only. Is it clear, right? So, now I want to operate all these operators on this function. Is it clear, right? Now, as usual, 1 upon d can be written as it is, right. I will multiply. So, 1 into normal multiplication, 1 into x square plus 2x plus 4, I hope I will get the same thing. Is it clear, right. So, minus I have written as it is, right. So, d of all these terms, right, d of all these terms means derivative of these terms, right. So, what is the derivative of x square? Derivative of x square is 2x, what I have written here, right, plus derivative of 2x is 2. Is it clear, right. Derivative of constant term is 0, that is why I have not written the 0. Is it clear, right. Exactly in the similar way. So, if you differentiate one more time, I hope you will get 2, right, minus 0, right. So, now you can simplify. After simplification, what will get? I have written 1 upon d as it is. So, after simplification, you will get x square plus 4. Is it clear, right. Now, as I have mentioned, d is the operator, capital D is the operator. Exactly in the similar way, 1 upon d is also an operator. Is it clear, right. So, 1 upon d stands for what, right. So, 1 upon d is an operator. Now, I want to operate on this function x square plus 4. Is it clear, right. So, here 1 upon d stands for integration. Is it clear, right. So, it means the same statement can be written down in this form, integration of x square plus 4 into the bracket dx. Is it clear, right. So, it means now I want to integrate these two terms, right. So, integration of x square is what? X cube by 3, right. So, friends, you know the integration formula, x raised to n, right. So, now you can use that formula, x raised to n. Integration of x raised to n is x raised to n plus 1 divided by n plus 1. Here it is x square, that is fine. I hope we can obtain x to the power 3 divided by 3, and integration of constant term, right. So, here 4 is constant, I hope you will get 4x, right. So, this is the particular integral of the given equation, right. So, now we can combine two parts, right, namely complementary function plus particular integral becomes the general solution of the given differential equation. Friends, I hope it is clear, right. Exactly in the similar way, you try to collect some more examples of the type x raised to m, and you try to find out general solution of the similar type of equations. Is it clear, right. So, now I want to concentrate on when the right hand side member is of the type sin ax or cos x, or as I have mentioned, it may be of the type sin of ax plus b or cos of ax plus b, right. First step is similar. First step is similar means it is understood that given equation is an non-homogeneous equation. Right hand side member is of the type either sin ax or cos ax or sin of ax plus b or cos of ax plus c, ax plus b. Our question is how we are going to find out especially particular integral in this case. Is it clear, right. So, we can write down in symbolic form, right. It means replace d by dx by capital D. Is it clear? I hope we can obtain 1 divided by a function of d. Is it clear? Right. So, then into sin of ax, you assume that right hand side member is of the type sin ax. Is it clear? Right. So, now I have to identify d square term, not d term. It may contain d term also, right. So, time being I will not concentrate on the term d, right. I will search or I will identify only d square term, right. So, because method says that we want to replace d square by minus times of a square. Is it clear? Wherever d square is there, no, simply we have to replace d square by minus times of a square, right, sin ax as it is. Remember, it is not minus a whole square. Is it clear? Because both are not equal. Minus times of a square is not equal to minus a whole square. Both are different. That is why method says that we want to replace d square by minus times of a square. I hope we will get a negative number in this case when we replace d square by minus times of a square, right. Suppose if you write minus a whole square, you will get a positive number. That should be observed. Is it clear? That is why while replacing d square, we must take care, right. We should replace d square by minus times of a square only, not minus a whole square. Is it clear? It is an important point to be remembered. Is it clear? Right. The same thing can be written as 1 divided by phi of d square cos of ax, right, is equal to 1 divided by phi of minus times of a square cos ax. It means it is exactly similar to sin ax. It may be of the type sin ax or it may be of the type cos ax, right. We want, in both the cases, we want to identify d square term and replace d square by minus times of a square. Whatever we will get, that is the particular integral of the given equation. Is it clear? Or more generally, we can say that 1 upon pi of d square sin of ax plus b, that is equal to, I will identify the term d square and I will replace minus times of a square sin of ax plus b, where a is what? A is present. It is an coefficient of x. Is it clear? It is an coefficient of x. Coefficient of x, right. It means a is a known value. Is it clear? Or in case of 1 upon pi of d square cos of ax plus b, right, 1 divided by phi of minus times of a square cos of ax plus b. Again I will replace d square by minus times of a square, right. So, why can't we solve one similar type of example, right. So, it is given that solve d square y upon dx square minus 4y is equal to 2 times of sin of 1 upon 2 x, right. So, here you observe what is the value of a. It is of the type sin of ax, right. So, before that you identify whether it is an homogeneous or non-homogeneous. Clearly given equation is an non-homogeneous equation. Is it clear? Right. Right hand side member is not equal to 0. Is it clear? And right hand side member is of the type sin of ax plus b or sin of ax. Then I want to use a particular method to obtain a particular integral. Is it clear? Right. So, before calculating into the particular integral, first I want to calculate a complementary function, because general solution of non-homogeneous equation containing two parts, namely complementary function as well as a particular integral, right. So, in the usual form, replace d by dx by capital D, it can be written as d square y minus 4y. Is it clear? So, y is common, you can take out y, what you will get d square minus 4 into y. Is it clear? Right. So, replace d by m. I hope we will get an auxiliary equation, m square minus 4 is equal to 0 or m square is equal to 4, or we can obtain m is equal to plus or minus 2 are the roots of the equation, right. On the basis of the nature of the roots, we are able to write down a complementary function. Is it clear? So, we cannot write it as a general solution, because it is part of the general solution. Is it clear? In the earlier cases, I think after calculating the roots, we have write down a general solution. Is it clear? Now we cannot call it as a general solution, because given equation is a non-homogeneous equation. That is why complementary function is the part of the general solution. That is why you want to call it as an complementary function only. Is it clear? That is equal to C1 into e to the power 2x plus C2 into e to the power minus 2x. Is it clear? Because roots are plus 2 minus 2. M1 is equal to plus 2, M2 is equal to minus 2. Okay. Now we are able to calculate a complementary function, right? Then how do we find out a particular integral in case of sin x? Is it clear? Right? As usual, you can write down in symbolic form. I hope you will get particular integral is equal to 1 upon f of d. F of d means d square minus 4. Is it clear? Right? So method says that we want to identify only d square term. Is it clear? And we want to replace d square by minus times of a square. Right? So what I have written here is equal to 2 is constant, right? 2 write as it is, 1 divided by, and I have replaced d square by minus times of a square. What is the value of a? A is 1 upon 2 minus times of 1 upon 2 whole square. Is it clear? 1 square is 1, 2 square is 4. That is why I have written here minus times of 1 by 4, right? And this constant I have written as it is. Is it clear? Right? So that is why you will get 1 divided by minus times of 1 by 4 minus 4 sine of 1 by 2x as it is. So this is equal to, I want to simplify, take the LCM and simplify. I hope we can obtain minus times of 8 by 17 into 1 by 2 times of x. Is it clear? Is the particular integral of the given differential equation. Now we are able to write down the general solution of the given equation as usual, right? Complementary function plus particular integral, right? No, we must write general solution after calculating particular integral. So if we forget to write y is equal to, right, complementary function plus particular integral, right, we will say that the method of finding the solution is not completed. Is it clear? Even though if we calculate separately, right, we must be able to write down the general solution, right? At least we should write in this form, short form, complementary function plus particular integral is the general solution of the given equation, right? So I request you to collect some more similar type of examples and you can practice. Is it clear? Right? And in some examples you may obtain the term d cube. Is it clear? Right? So as I have mentioned, we want to identify only d square, right? So you may obtain the term d cube. In that situation, or in such a situation, you can make it as an d square. Is it clear? How do you make d cube as d square? It is very simple. D cube can be written as d into d square. Is it clear? D into d square, and d square can be replaced by minus times of a. Again you will get in terms of d. That is why you want to multiply its conjugate for numerator and denominator. Then again it becomes d becomes d square. Then again you can replace d square by minus times of a square. Is it clear? Right? So I hope you will practice a similar type of examples. Right? Friends, we want to move into the another type. Right? So namely, when the second member f1x is of the form e raised to ax into v, right? So where v is a function of x. Is it clear? Right hand side member is of this type. How we are going to calculate a particular integral? In the usual form, we can write down 1 upon f of d e raised to ax into v. Right? So it can be written as e raised to ax into 1 divided by f of d plus a into v. It means that right, in f of d, wherever d is there, no, I have to replace d by d plus a. A is what? A is the coefficient of x. Is it clear? Right? They will give in this form. Right? So now I want to identify f of d, replace d by d plus a into v. Is it clear? Right? For example, given equation may be in this form, d square y upon dx square plus y is equal to x into e to the power 2x. Is it clear? Right? So you observe the right hand side member, clearly it is a non-homogeneous term, Is it clear? X into e to the power 2x, right? It is of the type x into v. Is it clear? Where v is e raised to x into v. E raised to x into v means e raised to 2x into x. V is equal to x. Is it clear? We want to find out the solution. How we are going to find out the solution? In the usual form, write down an auxiliary equation, right? Replace d by dx by capital D. D square plus 1 into y is equal to x into e to the power 2x. Is it clear? Replace d by m. I hope you will get m square plus 1 is equal to 0 is the auxiliary equation. Therefore, m square is equal to, you can take this term to other side, you will get minus 1, right. So, m square is equal to minus 1. Therefore, m is equal to, I hope you will get plus or minus I, right. So, roots are complex. It is of the type alpha plus or minus I beta. Alpha is equal to what? You can replace alpha by 0. Is it clear? Right. And beta is equal to what? Beta is equal to 1, coefficient of y. Is it clear? So, when we write plus or minus I, it is understood that it is of the form alpha plus or minus I beta. Is it clear? Right. I want to remember alpha is equal to 0 and beta is equal to 1, because those two values are required to write a complementary function. Is it clear? So, on the basis of the nature of the roots, we are able to obtain a complementary function of the form a into cos x plus b into sin x. How do you get a into cos x plus b into sin x? Here a and b are arbitrary constants. Is it clear? As I have mentioned, in this alpha is 0, we can write down e to the power 0x. E to the power 0x means e to the power 0. E to the power 0 means it is 1. That is why I have not written e to the power 0x. A into cos beta x, right. According to the superposition principle, I want to write cos bx. Is it clear? Right. I have not written beta because beta is equal to 1. So, 1 into x. Is it clear? Exactly in the similar way, b into sin beta x. Beta means 1. Right. I hope we can obtain a complementary function. Is it clear? Right. So, now we want to find out particular integral. How we are going to find out a particular integral? So, 1 upon d square plus 1. Why it is d square plus 1? It is f of d. Is it clear? Right. Replace this term by d square, coefficient of y is 1. We can obtain d square plus 1 into a right hand side member. Whatever they have given in the differential equation, we want to write the same thing, x into e to the power 2x. Is it clear? Right. So, method says that I have to replace d by d plus a. Right. A is what? Coefficient of x. Is it clear? That is why here I have written e to the power 2x 1 divided by d plus 2 whole square plus 1 into x. X means p. Is it clear? Right. So, now I want to simplify d plus 2 whole square plus 1. Right. It is of the type a plus b whole square. Right. So, you can expand e to the power 2x 1 divided by d square plus 4d plus 2 square plus 1 means I hope we will get 5 into x. Is it clear? Right. So, friends, you observe it is of the type 1 upon f of d into v. Again, v is a function of x. Is it clear? So, once again I have to find out what is the particular integral of 1 upon f of d into v. Is it clear? Right. Depending upon the v, I have to choose a method. Right. Here v is equal to x. X means it is of the type x to the power m. Right. So, now I want to use that method. Just now I have explained how we are going to find out a particular integral in case of x raised to m. Right. So, using that method I can able to find out particular integral of this term. Is it clear? Right. I cannot say that this term itself is the particular integral. Is it clear? Right. So, I want to remove all d's, operator d, because it is containing d square d. I have to remove all these operators. Is it clear? Then only I can call it as a particular integral. Right. But still this term containing d. Right. So, if I want to remove, then once again I have to apply the method of the form x raised to m. Is it clear? Right. So, that method says that I have to identify the lowest degree term from f of d. Is it clear? It is containing 3 terms. What is the lowest degree term? 5 is the lowest degree term. That is why I can take out 1 divided by 5. Is it clear? And remaining thing can be written in this form 1 plus d square plus 4d divided by 5. If I take out 5 from all these terms, it can be written as 1 plus d square plus 4d divided by 5, right, and I have written in a numerator, that is why it is negative power, is equal to the power minus 1, right. So, into x. Now, I want to expand it binomially. It is of the type 1 plus x to the power minus 1, is it clear, right, and I know that the power of x is 1, is it clear. That is why I can write down only 2 terms, is it clear. That is why I have written here e to the power 2x as it is, 1 by 5 as it is, right. 1 according to the formula I can write down 1 minus x, is it clear. The power of this term is 1, because the power of x is 1, is it clear, right. So, that is equal to, I want to multiply 1 into x, I hope you will get x only. Then d square is an operator, I want to operate on x, is it clear. It can be written as d square divided by 5 of x. D square means a second derivative of x, is it clear. I hope a second derivative of x becomes 0, plus it can be written as 4 divided by 5 derivative of x. Derivative of x is 1, is it clear, right. I hope on simplification you will get e to the power 2x as it is, already 1 by 5 is there, 4 by 5 means, so you will get 1 by 25 into 5x minus 4, right, is the particular integral of the given differential equation. So, therefore, general solution of this equation is of the type complementary function plus particular integral, right. I request you to select similar type of examples and you try to find out some more examples on the basis of e to the power ax into v, is it clear, right. So, friends, when the right hand side member may be of the type x into v, is it clear. So, in this case, how do we find out a particular integral? X into v means, say for example, x into sin x or x into cos x or maybe x into e raised to ax, is it clear, right. So, in that case, how we are going to find out general solution, is it clear. First part is as usual, you can find out the complementary function. Second part is you can write down in this form 1 divided by f of d, is it clear, x into v, again where v may be a function of x, is it clear, right. So, this can be written as x minus 1 upon f of d into f dash d into 1 upon f of d into v, is it clear. It means when the right hand side member is of the type x into v, now I want to use this formula, is it clear. So, method says that, so we must use this formula, right. So, now we can solve from this side. This side means first I want to evaluate 1 upon f of d v, right. Again v may be any one of the previous type, is it clear. So, for example, it may be of the type e raised to x, it may be of the type sin x, it may be of the type cos x, right. Suppose if it is cos ax, then I want to use that formula. I want to identify d square, right, and I have to replace by minus times of a square. If it is of the type x raised to m, then I want to use that formula, is it clear. Depending upon v, now I have to evaluate, then I will multiply from this side. So, like that I can evaluate, is it clear, right. So, you can solve one similar type of example, d square y upon dx square minus y is equal to x square into cos x, right. So, you can practice this example, is it clear, right. So, why I am mentioning this example? So, there is a specific reason, is it clear. It is given that x square into cos x, is it clear, right. So, our formula says that right hand side member is of the type x into v, right, but here given function is of the type x square into cos x, right. So, x square can be written as x into x, is it clear, right. So, it means this function becomes x into v, where v is equal to x into cos x, is it clear, right. So, it means same formula can be used repeatedly, right, x into v, again it becomes x v, is it clear. I want to apply the same formula repeatedly. I hope you can practice this example, Is it clear, right? Similarly, you can practice d square y upon dx square plus 4y is equal to x into sin x. Is it clear? Now, I am going to solve this example d square y upon dx square plus y is equal to x into e to the power 2x, right? How we are going to find out the solution of this example, right? I hope you can we are able to find out the complementary function. I am not concentrating on a complementary function. I will leave it to the students. I hope very easily you can find out two roots and you can find out a complementary function. Write down the complementary function after obtaining roots. Depending upon the nature of the roots, you are able to write down a complementary function, right? So, now I am going to concentrate on how we are going to calculate particular integral. Is it clear in this case, right? So, it is of the type x into v. It can be written as 1 upon d square plus 1 x into e to the power 2x. Is it clear? According to the formula, I have to write x minus 1 upon f of d into f dash d. F dash d means I have to differentiate d square plus 1, right? So, derivative of d square is what? Derivative of d square is 2d. Is it clear? Derivative of 1 is 0. That is why I have written 2d into 1 upon f of d. Again, f of d means d square plus 1 into e to the power 2x. Is it clear? As I have mentioned, now I want to find out what is the particular integral of this term. Is it clear? I want to observe this function. It is of the type exponential function, particularly namely e to the power 2x. Is it clear? Right? So, that is why I will write this part as it is. Is it clear? X minus 1 divided by d square plus 1 into 2d, right? So, according to the method, I have to replace d by a. Wherever d is there, no, I have to replace d by a. A is what? Coefficient of x. That is why I have replaced d by 2. 2 square plus 1 e to the power 2x. Is it clear? That is equal to x as it is 1 upon d square plus 1 into 2d as it is. Is it clear? Simplify 2 square means 4, 4 plus 1 is 5, 1 by 5 into e to the power 2x, right? So, that is equal to, now I have to multiply x into normal multiplication 1 by 5 e to the power 2x. Is it clear? Right? So, minus 1 upon d square plus 1 into 2d into 1 by 5 e raised to 2x. Is it clear? Right? So, we know that d is an operator, right? I want to operate on this function. Is it clear? So, 2 by 5 is constant, you can keep as it is. I want to find out derivative of e raised to 2x. Is it clear? Derivative of e raised to 2x is what? 2 into e to the power 2x. Is it clear? Already 2 is there, that is why you can obtain 4 into e to the power 2x divided by 25, 5 into 5. Is it clear? Right? So, it means you can find out a particular integral. Is it clear? Right? In this form, right? Then you are able to write down a complementary function plus particular integral as the general solution of the given differential equation. Is it clear? Right? So, I hope you can practice some more examples on the form x into v. Is it clear? Right? So, friends, now so far we have practiced some methods on particular integral. Is it clear? Right? So, sometimes when the right hand side member, right, may not be of the same type, means whatever so far we have discussed. In that case, so we need some more methods. Is it clear? Right? So, in that direction, so we shall discuss about the method of undetermined coefficients. We will focus our attention to the simpler topic of non-homogeneous second order linear equation with constant coefficients, namely a into y double prime plus b into y single prime plus c into y is equal to g of t, right. So, where a, b, c are constants, a is not equal to 0 and right hand side member g of t is not equal to 0, it has a corresponding homogeneous equation a into y double prime plus b into y single prime plus c into y is equal to 0. Is it clear? The method of undetermined coefficients or sometimes referred as the method of judicious guessing. It means in this method we are going to guess the particular integral depending upon g of t. That is why it is called judicious guessing. Is it clear? Right. So, it is a systematic way to determine the general form or a general solution. Is it clear? Of the particular solution y of t based on the non-homogeneous term g of t. Is it clear? In the given equation. Right. Now, as I have mentioned, I have to observe right hand side member. Right. Depending upon the right hand side member, I have to guess a particular function along with the arbitrary constants. Is it clear? Then I have to verify whether our assumed solution satisfies the given equation or not. Right. How we are going to verify? Say for example, if I assume y of t is equal to, then I have to obtain second derivative of the assumed solution, first derivative of the assumed solution, then I have assumed y is equal to, then I have to substitute in the given equation along with the right hand side member. Is it clear? As I have mentioned, our assumed solution may contain arbitrary constants. Is it clear? I will substitute in this equation, right, and after simplification I can obtain the arbitrary constants. Is it clear? Then finally I will substitute in the assumed solution, right. So, it means the basic idea is that many of the most familiar and commonly encountered functions have derivatives that vary little from their parent functions. Is it clear? So, it means parent function means g of t. It may contain an exponential function, or it may be of the type polynomials, or it may be of the type sine and cosine. Is it clear? Right. Consequently, when those functions appear in g of t, is it clear, we can predict the type of the function that the solution y would be. Is it clear? On the basis of g of t, we can assume, right, and write down the best guess from y, form of y. Is it clear? Leaving the coefficients undetermined. Is it clear? Right. So, friends, so exactly in the similar way we can guess a particular integral, then we are able to find out the arbitrary constants. Right. I am going to discuss in detail about the method of undetermined coefficients in the next class. Thank you very much.